Hello friends, welcome to my channel Meko Sapiens. Today we will be learning how to optimize portfolio to maximize the Sharpe ratio, which is typically portfolio returns per unit risk that we have to take or it is subjected to. For this, we will be needing quant mode, library, portfolio analytics, performance analysis, and NSE2R. Quant mode is for getting the data from Yahoo Finance. This is for optimization function. This is for visualization, and NSE2R is dedicated library for National Stock Exchange of India. Our first variable will be stock names. NSE2R. This should get us the stock names. See here. So okay, we got these stock names, all 50 stock names of Nifty 50, and we need only the symbol column. Rest all we don't need. So we make one more variable equals, and we will call stock names symbol column of stock names. And since we want to download it you from Yahoo Finance, we need to have and get Nifty data. So we need to have .ns after it. Okay. Stock names, dollar symbols. Yes, it should do .ns. To get data for ASE, we have to write .bs, but to get data from NSE, we will be writing .ns. So all 50 names .ns. Yes. Now we will introduce one more variable called since. This is a date, as you can see, 1st January 2017. We'll be needing it to download the portfolio prices. One more variable, portfolio prices. We'll be using a for loop, so defining it null for ticker in tickers portfolio prices to be assigned with C bind. First column will be with symbols, and second column will be closing prices of those symbols using Yahoo function. Get symbols from Yahoo. From is the date from when the historical data has been downloaded. Since and your DCT should be Delhi. Sign false, and we will be needing only column number 6. Yes. Since the column number 6 is the adjusted closing price, and we will be needing only adjusted closing price. So let's make one more variable called funds, and the funds will be symbols that we just extracted. So the funds will be the portfolio, will be these column names. Yes, column names. Okay. Just before that, let me calculate portfolio return. So ROC prices. So portfolio return, basically daily returns are closing price of day 2 minus closing price of day 1 divided by closing price of day 1. So as you can see, it contains NA values not applicable for the first row. So let's modify our function with NA dot omit. This should remove NA. Okay, removed. Now we need to call the column names of portfolio return data set and call them as funds. So if I call funds, yes, it should show me the column names. Let's start optimization, and for that we'll make initial portfolio, and let's start with portfolio specs. You can read portfolio analytics PDF menu, to understand these functions even better. I won't be covering them. And then we need to add constraints. So oh, yes, portfolio unit motive. Okay, type full investment. Since we want the weightage, the total weightage to be 1. Unit portfolio, constraint portfolio, unit portfolio type long only, so none of the weightages would be 0 or negative. Or F. And now we are adding an objective. Return. So this usually is the mean of daily returns of the portfolio prices data. Yeah. Let's see what all constraints, full investment and long only, and objectives we have defined. Okay, let's set a value for maximum package. Minimum sum should be 0.99. Maximum sum should be 1.01. So we are giving some deviation, so our random optimization can run. Let's add one more objective of standard deviation. It would be risk, as we know. Sharpe ratio is reward divided by risk. NEM. Where is NEM? Okay, no issues. It should do with multiplier of 0. Okay. Now let's make one more variable open to add additional constraints. The portfolio would be the initial portfolio only. Additional constraint will be diversification. Don't make a spelling mistake in it. Diversification. Mm, minimum value of which could be 0, maximum 1. In this particular constraint would be having index number 2. So this is second most prior constraint. It one more constraint portfolio equal to initial portfolio type risk. No, with no multiplier. Okay. Name identification. So, I am writing one more variable. Maximize Sharpe Ratio using Sharpe Ratio portfolio using random portfolio. So RP function will be optimize portfolio should be equal to uh, portfolio return. Yes, this is return portfolio equal to portfolio equal to one. Optimization method is random. Let's set a search size. I have tried 1 lakh as well, but it will take a lot of time. Hours maybe. So let's try only 1000. This is maximization of Sharpe ratio. This constraint has to be true, and all 2000 portfolios to be traced, so we can plot them. So this will call the weightages. Okay, it's run already. It gives us mean return of 0.13% daily return. And these are the weightages. Let's sort them and plot them. Oh, let's extract the weight. Mix is dot weight. Uh, extract its mix is rp. We should extract the bits and then mix is return rp. So we will calculate. So now we will calculate uh, return of the portfolio if Nifty 50 components had these weightages which were calculated by optimization method. It's equal to this mix is weight dot rp, and okay, let's simply take this index return dot portfolio and copy it. Mhm. this index falls, contribution falls, rebalance. So we can rebalance, but for this application, let's select not applicable. Yes, we don't need it. Okay, we got some value, and I want to change the column name of this return function, this return data set, and set this as random portfolio return. Okay, I should have called this. Yes, now it's working. Let's call it maximum Sharpe ratio return. So these are the return with random optimization approach. We'll be plotting it against some benchmark. Let's try one more optimization approach using ROI optimizer. For this, we will make another initial portfolio. Okay, let me copy the whole thing. This whole thing. I think okay. Only this just need to be changed. After ROI, we don't need to give any deviation. So this will be okay. Port two, port two, in portfolio two, in two. Here, let's call it ROI. This will be port two. Here, ROI, we can set it 20,000. That's the beauty of ROI. It don't take much time. Okay, you have to run the script from here. It should give us some weightages. Okay, given already. Some new weightages are there. Okay, I cannot see it. But we will trace it, extract the weights. Sorry, this should be ROI. This should be ROI. So ROI weights have been extracted, and this should be ROI here. ROI. Okay, and let's change the column name to ROI portfolio return. Yes. Now let's make. Let's just check the. Let's just make a benchmark. So Nifty 50 prices. Similarly, let's get Nifty 50 prices. What if instead of doing all these things, someone buys a Nifty? What would be the returns? So we'll be comparing returns from that. So this should give us an this is a symbol for Nifty 50 from the same date since periodicity will be daily. This auto assign false. and we want to take only the adjusted closing prices. Okay, download it. Now let's check 50 done and it commit ROC 50 prices. Yes. Now let's change the column names of Nifty 50 return to Nifty 50 returns. Okay. Now let's check the ROI. Let's check the Sharpe ratio with ROI. Uh, ROI returns. Okay. So we'll use this table dot annualized returns, which will give us mean for a particular portfolio, annualized mean, annualized standard deviation, and the Sharpe ratio. So returns like ROI, I am calling the X return ROI, L, applicable, the RFS risk-free return. Let's consider zero. You can have some risk-free return also, uh, like the return FD gives, but let's consider it to zero. Geometric, yes, it should be geometric, not logarithmic. Something came out, something got it. Let's repeat it for the random portfolio. We will change only this. Okay. Let's repeat it for empty. Yeah, I will just replace this and let's now make a table. Cbind calling SR dot ROI, SR dot RP, SR dot Nifty. So we get a table. Let's see who is giving better ROI. Oh, random portfolio return. So this will be giving better Sharpe ratio. Let's go with this then. Hmm, cool. With 38% return, which would be subjected to 22% standard deviation. Okay. We can plot efficient frontier as well. Let's give one more variable EF for efficient frontier. I don't remember the syntax, so let's type the function console and copy from the help menu. This object, let's make it. So let's take the random portfolio optimization values. Okay. Let's since it is giving the since it is giving better Sharpe ratio. Yeah. Remember we had turned on the SS. Stresses were true, so it should plot That's a strange. Okay, that's because we don't have ES in our column in our constraints. This conversion is max SR for this time. Let's introduce one more variable E. For efficient frontier, we will plot it. We'll plot the efficient frontier and let's get the syntax from help menu. Extract efficient frontier object would be x sr.rp, and instead of es let's set standard deviation. Okay. uh, for visualization, let's make one return table data frame. See, let's include na.omit also. If Nifty don't have return on some date, then so this data frame would be including return from ROI method, max return from random method, and then 50 returns. Wow. Yep. So this table is made. Okay, now let's go to interactive chart. You are gonna like it. F. What in none? Let's use. Okay, you may be needing to install it first. Install Plotly library. Let's get name. Uh, Profit loss. Mm, okay. Let's plot it. This should not take a while. Till then, weights. So till then, let's sort the random portfolio weights. Okay. Graph is ready. Yeah. As you can see, beginning from 1st January 2018, November 2017. Okay. Till date, it has the random portfolio has increased 3.2 times, while the ROI portfolio has increased 1.6 times, and Nifty 50 has increased 0.45 or 46%. So this gives the cumulative return. This is daily return, and you can see the random portfolio is the one which deviates the least. See when the oh, apology, pardon me, the random portfolio is one which is dropping more here. Okay, so the top one gives the cumulative returns and the bottom gives the daily returns. So quite helpful. Mm, it's my bad. It decreasing to. So these are the weights. So we should be uh, investing 68.6% in Bajaj Finance, 20% in Tata Consume, 4.6% in UPL, 1.2% in Aisha, 1.2% in Hindalco, and 1% in Hindustan Unilever HUL, 1% in Asian Paints, zero point 0.10 in HCL, zero point 0.6 in HDFC, zero point 0.6 in Infi, and zero point 0.4. So these are the weightages. We can make a basket, and using a small case, we can make a basket and track it for some days. If we found that I usually do make a basket using these weightages, and then I wait and track the index for around 1 or 2 months, and then I invest. So I found it helpful. So I hope you found this video helpful. If you do, please like, share, and subscribe. Thank you.